What's the número en el board? El año pasado ha sido muy duro. Sí, pero
Welcome.
era necesario. ¿Cómo ves este board? Yo creo que bien. Se va a poder hacer muchas
So welcome
cosas.
everybody. Thank you all for coming on short notice. I know this was only announced very recently, but it was really in response to probably some of your questions during parent night. And I want to say two things. First off, I want to say there it is. I'm sorry. And what I'm sorry about is I'm sorry that we've not had this meeting until now. Because we've been doing a lot in mathematics that we're really excited about. And I'm really excited to share it with all of you and how it impacts 7th grade in particular. I've wanted to share for a while. We got caught up in all kinds of stuff going on last year we now have a wonderful team together, and I've got time to share this with you. So thank you for indulging me with a little bit of patience until we get this to you, and I'm really excited to talk about it. So that's my excitement over on the right-hand side there. So in order to tell you a little bit about mathematics, and how and why we're doing some changes in 7th grade, and actually all through K through 12. But I've got to tell you a little bit of history, and I'll tell you a little bit about the Common Core and a little bit about grade 7 math standards in particular, and also along the way some changes because of this history. Things like the SAT has had changes as well. And at the very end, I'll give you a little bit of an idea of where we're going in other parts of the school as well. So first off, this story starts quite a long time ago. In the United States, not so long after I graduated from high school, there was a test that you might have heard of called the TIMSS test. It was a test of mathematics and science that was international. And the results of that TIMSS test essentially said what came as a surprise or a wake-up call, if you will, to many people in the United States that essentially American kids were not doing very well with respect to their international peers in mathematics and in science. And this was really a great concern. And you might remember some of these results. You might know that that's when it came out that Singapore and Finland and South Korea were doing really good jobs, as well as a number of other countries. But the United States was falling a little lower, and a little lower than what they wanted to be. And so what happened? And particularly things like statistics and probability, problem solving, mathematical modeling, and reasoning. Some of these things that, when you think about those things, those are many of the things that in modern jobs, that's what you're going to need. You're not going to need to do arithmetic arithmetic's important, but you're not going to have a job that can be done by a calculator. These are some of those skills that are extremely important for us in a modern world. Yet those were the very things that we were falling behind upon. Are on. And so the response in the US was, people said, well, and there was actually amazing agreement politically, which, as in many countries, rarely does anybody agree on both sides of things politically, but actually these tests actually got people to say, look, there's a problem and we need to fix it. And it started a movement to create some standards, because as you might know, education in the US is very decentralized. And so first, there were standards created for math and science according to states. So different states had different standards. And then this idea of what's called the Common Core was these different states coming together and saying, why are we all doing this independently? Why don't we pull this together? And what came out of it was really a very nice piece of work. What they involved mathematicians, they involved people in education, they involved psychologists to make sure that the sequence of topics was appropriate for kids at their ages in development, all the way from kindergarten up through 12th grade. And they involved people in policy and politics as well to make sure that, that all of this could be implemented. And it was really quite a nice piece of work. And one thing I should say is, before this, particularly in the United States, like I said, there was not much centralized control, and so school districts were largely up to their own for how they designed their own mathematics curriculum. And so, one school might be quite a bit different than another school in another place. And, that's not like we have here in Bolivia, where we have a Ministry of Education that prescribes certain things. In the US, it wasn't that way. And it was only until these efforts that that really got put together. Still, it's not mandated, but it's put together in this way. The other thing they did in this effort is they went and looked at those countries that scored really high on that TIMSS test. So they went and looked at Finland, and they went and looked at South Korea, and they went and looked at Singapore, and they took the best parts of those and incorporated them in here as well. And I'm not quite sure how they get this statistic, but in some of the papers they say there's a 90%, a little bit more than a 90% overlap between all those different countries in the Common Core. So there's widespread agreement. It's not just in the U.S., but in these other high-scoring countries of what is the appropriate things to be taught at different levels. Now, of course, somebody will, one person says it should be in third grade, and the other one says it should be in second. There's some minor disagreements, but it's largely the core content is very similar. So what they produce? Well, they produce some standards that are very sequential, kindergarten through grade 8. In high school, because the U.S. is very decentralized, the high school standards were developed as a whole, but they weren't sequential in the same way that the kindergarten through 8th grade standards were. And what this, this is a little example of a particular area, showing how some of these ideas progress. But they all progress all the way from kindergarten up to 8th grade. And one thing that's interesting is, some people say, well, when does something like algebra start? And the interesting answer to that question is, pre-algebra really starts in kindergarten. Because when you say, we've got 4 things here, and we've covered some number of them with a box, and then there's 9 in total, and you're trying to figure out how many might be in that box, that's really algebraic thinking. It doesn't have the symbols that we're used to with algebra. That doesn't come in until 3rd grade. But we've got those ideas building all throughout this in a sensible way, in a way that is appropriate for all of these different levels, and introducing them at the right time. So, with this program, the psychologists were happy as well as the mathematicians, which isn't an easy thing to do. So what about ACS? Well, I'm an optimist, but I feel like sometimes we have to face some brutal facts, and the brutal facts are that ACS adopted these standards about a decade ago, but we didn't do the teacher training, we didn't do the implementing it with any kind of fidelity, and a lot of I should say, there's some reasons for that, and we're not alone in that. Many schools in the U.S. also didn't do the implementation with fidelity, and didn't do the teacher training, and didn't have the results that they could have. One factor that really hurts that is publishing companies produced books that were, you can imagine, it's in the interest of a publishing company to keep its books largely the same. Because you've got teachers that have been teaching it for 600 years that want to just keep doing the same old thing, and if you change the book too much, they don't like that, and the district doesn't like to change too much, and so there's some incentives for the publishing companies just to do the same thing. So many of them, when these standards came out, they just took the same chapters of the book that they always had, and they pasted the names of the standards on top of them, even though when you look really closely, there's not a lot of alignment there. So it really takes some extra work to go back through and really look at these standards, really look at, at your teaching practice as a teacher, really look at how you're teaching it as well. And it takes a lot of work and a lot of training to really do this right. But when you do get it right, as many of the top international schools in the world have done, when you do get it right, it really has dramatic effects on student performance. And so that's what we're doing. We're going to get it right. And I want to tell you a little bit about so what happens what are the themes in 7th grade for the Common Core? Well, one of them is ratios and proportional reasoning. And if you think about it, really reasoning deeply, well, I should say, I used to teach a teacher training course at the University of Washington where we spent a long time with adults on ratios and proportional reasoning. When you really think about ratios and proportional reasoning, it's not so easy. But ratios and proportional reasoning acts as a bridge between the fractions that they've learned before and the algebraic reasoning that's coming next. And so it's a nice bridge there. The number system, expressions and equations, so they're getting that algebra right here. There's geometry, and then there's that statistics and probability, which I'm going to mention a little bit more later on. And I'll tell you about some of the consequences of some of the things that we've done in the past. So one question that many people have, and it's a very legitimate question, is students learn differently, right? There are students that are racing ahead. There are students that are struggling. How do we deal with this? And I'm first going to tell you a couple ways that aren't particularly effective. And this one is one that we've done in the past quite heavily. We've kind of haphazardly accelerated kids. And what happens is it often leaves gaps that end up impeding their understanding in the future. And I can actually tell you from the experience of being a physics professor on the other end of things, that many kids do come with conceptual gaps. I've had many kids that come in that can do the calculations, but they can't do the thinking that involves. So they've learned to memorize it, but they didn't spend enough time with the fundamentals to understand what they're doing. And that oftentimes is much harder to fix than the other way around. But I want to show you, rather than talking about that end of it, I want to show you a specific thing that has impacted us. A number of people have mentioned to me at ACS that lots of kids get extra tutoring when they're taking the SAT. And the truth is, we need to be preparing them in our math classes so that they don't need much tutoring to do the SAT or none at all. The problem is, by skipping over some of this, the SAT actually changed in 2016. And the way that it changed is it actually changed to be much more consistent with the standards that I just talked about, because all the schools had begun changing, and so the SAT also changed to fit that model. The problem is, our instruction here didn't change. Our instruction, in fact, carried on with just a little historical aside. The model that we've had, the pre-algebra, algebra, geometry, algebra model, was developed in the late 1800s, and it's not changed as much as it could have in those times. And so the SAT did change, and the SAT began focusing on some of those topics that really don't appear in that algebra, geometry, algebra sequence, namely the problem solving, statistics, and modeling that we're now bringing in all the way kindergarten up through 7th grade. I'll tell you how we're proceeding forward with that. Actually, it changed again in 2023, and it's now focusing even more so on critical thinking and reasoning. So again, these higher level skills. And this happens to be its current distribution. The statistics and probability are heavy in that section here. Another thing that's come up relatively recently, this is well, I mean, it's not the only one that says this, but here's a quote from a relatively recent paper that looked at students when you split them up or when you bring them into the same class, when you detract the classes and you put everybody together, but really engage students, and that's the critical part here, engage students in rich tasks and formative assessment. Student achievement on state tests increased dramatically for students at all levels. And what ended up happening is it wasn't just the high achieving students that went up or the low ones that went up, but they all went up, including the middle. And so the solution to students learning differently isn't pulling them all apart. So what is it and what does it look like? Well, here's here's a little example. You may or may not like this particular example, but I can give you an idea for what types of things can happen. So here's a standard. Use properties of operations to generate equivalent expressions. And it says apply those properties of operations as strategies to add, subtract, factor, expand linear expressions with rational coefficients. So that's a lot of verbiage, but here's an example of what we might have seen, and it's an example that our students still see as well. You've got something like this, an expression like this, and you ought to be able to say, well, that's the same as 2a plus half of 7 times b, or 3.5 times b. So that might be something that we're expecting of everybody. But if you have a class of students, we might extend this idea with a task that's a little more complicated for students who might be prepared for it. And this is really a neat problem if you think about it for a little bit. So let me just let you read that. So it's using the digits 0 through 9 at most one time to make this equation true. If you kind of think for just a moment about some of the thinking you have to do that. If you think through it, you'll probably find yourself doing a lot of trial and error, but doing a lot of the, you're practicing implicitly the process that you're doing up above, right? But you're checking that over and over again against different things. You're looking at patterns of different numbers. Maybe you're looking at those 2-digit numbers and thinking about what kind of patterns emerge from plugging different things in there. You're frustrated that you can only use everyone once, but it's a deeper level of thinking. And this is kind of you might say this is somewhat of a surface example, but there's lots of examples like this throughout mathematics, where, I mean, if you really think about it, almost any one of these standards, almost any topic in mathematics, there's a graduate level course being taught on that topic, but at a much, much deeper level. So you don't skip over the probability and statistics, you don't skip over these topics, but rather you go deeper into them for the kids that are able to, and for the kids that are struggling, you scaffold it with examples and parts that are focusing on the same standard, but they're not taking it quite as deep. This takes skill as a teacher. Let's see. Sorry. This really takes skill as a teacher, but we now have, for instance, our 7th grade teacher just spent some time in the summer in the U.S. with a workshop put on by the U.S. State Department that focused on these same standards, these same techniques, and she was exposed to people from around the world in other very good international schools, and saw that this isn't something we made up here. This is something that all the best schools are doing right now, and she's now plugged into a community that's working on that. We're also providing training and coaching all the way throughout right here at ACS. She's been meeting all the time and planning with people, and is really excited about these new things. So yes, this is hard. It's not easy, but we've got support there to make sure that our teachers are able to do that and do it effectively. I should say, when you look back, I'm sorry to say, but the brutal facts were that our results were not where they needed to be compared to top international schools. But we've taken aggressive steps to get us there and make that disparity come to an end in our elementary school, and now we're taking those same steps in our middle school, in 6th and 7th grade very aggressively this year. And I can assure you I'm not going to stop this until we've got ACS math where it needs to be. It's a passion for me. I'm a physicist by training, and I've trained a lot of teachers on teaching physics and physical science and mathematics, and it's something I'm passionate about, and it's time to fix it, and we are fixing it.
Andrew?
Yes?
Where did you get the results from? From the map test?
Yes, from map test, but even anecdotally as well. I think we can look even on some of our internal assessments as well, and see that there are some gaps between the kind of reasoning that we want them to be able to do and the kind that they're doing currently. I just want to say also, this doesn't end at 7th grade. We have a team that is now looking at our curriculum from 8 to 10. Like I said, the sequence is well specified in the Common Core up through 8th grade. But then it begins, then there's a lot of choice in the high school level, the 9 through 12 level. And so we've got a team that's we actually have a room that they've got these standards pasted on the wall in different places, and we're taking those apart and we're reconstructing our courses from 8 to 10 to make sure first that they match the standards, and secondly, that they're going to lead to a couple different pathways. And the pathways that we're trying to design, and they are the kind of pathways that our students are taking, where they want to be heading now. One of them will be a calculus pathway. A lot of our students currently take AP Calculus AB or BC or sometimes both. And so we're making sure that we're preparing them for that pathway. But also, what's become a pathway into a lot of other careers is a pathway that focuses a little bit more on data science or data analysis, probability and statistics as well. And so if you can imagine, a lot of the social sciences, very heavy on statistics. A lot of what company, it used to be only the social sciences, right? But, now, how many companies are hiring people with backgrounds in data science that often combine a little bit of programming and the mathematics as well to pull information from all the data that we're swamped with. And so we're trying to build those pathways at the end as well. We've also discussed as a community the possibility of bringing in an IB program. If we brought in an IB program, the IB also has a 2-year program at the end, 11 and 12, and they have 2 math courses, each that can actually be taken at standard or higher level, but one of them focuses heavily on calculus, the other focuses more heavily on probability and statistics. They both hit both topics, but one more than other.
And what about maybe finance or things? There might be people, I never saw calculus after I did calculus 1 here, calculus 2 at college, never saw it again. Which I think most people probably didn't. Maybe do other things
I'd say
just calculus.
I'd say this course here, I've written down data science, but we really haven't settled on a title for it. But it would definitely involve more probability and statistics, more things that aren't the calculus base, and that might be as that forms, I think that would probably, that would be the place where we would encourage people that were planning on going into finance, and so we would, naturally, I think that would be a nice place. But like I say, we haven't fleshed out exactly what that might look like. But thank you for that input, because I think it's a good
Science.
Yeah, there's a lot from economics. If you can, you can imagine a lot of projects, economic-based projects that you might put into that course. Let's see. So, to conclude, I just want to say that, that we are fixing this. I see it as a extremely positive thing. I think the sun is coming up and we're getting things straight. I recognize that we haven't been where we needed to be, but we're changing that. And that's all I've got, but I'm happy for questions.